So today what we're going to be working on is the half-life formula. So the half-life formula is A equals P times 1/2 raised to the T over H power. So just like the other day, A is your final amount. P is your initial value. Or your starting value. T is your time. H is your half-life time. So there's two times in this. One's half-life and the other one's just regular time. So you'll know when it's half-life time because it'll actually say half-life time is whatever. Okay, so let's take a look at the first problem. So it says a radioactive isotope has an initial mass of 25 grams. The isotope has a half-life of 4 days. After 13 days, how much of the isotope will be left? Round to your nearest tenth. Okay, so let's write down the formula for half-life. A equals P times 1/2 raised to the T over H power. Okay, so we have here the initial mass, that's your P, is 25 grams. The half-life, that's your H, is 4. 13 days, because we want to know how much is left after 13 days, that's your time. And we want to know how much is left, that's what we're looking for, is A. So we have A equals 25 times 1/2. If you want to use 0.5, you can use 0.5. Raised to the 13 over H, which is 4. Okay, so that you could just plug into your calculator at one time. So put me on pause and then plug it in and get your answer. Okay, so when you plug this in, you get 2.6278 to the nearest tenth would be 2.6 grams. So after 13 days, there'll be 2.6 grams left. Okay, so let's flip it over. Okay, so number 2 says iodine 125 has a half-life of 2 months. If 65 ounces of iodine 125 is left on a counter in a lab, how long will it take for only 10 ounces to be left? Round your answer to the nearest ounce. All right, so let's write down the half-life formula. A equals P times 1/2 to the T over H power. All right, let's mark down what we know. So iodine 125. So this 125 is nothing. That's just naming the iodine because there's different types of iodine. So we have a half-life. So that's your H is 2. 65 ounces is left on the counter. That's your initial value, P. How long, which means I'm solving for T, not half-life, T, will take for 10 ounces to be left. That's your A. All right, so we have A is 10 equals P is 65 times 1/2 raised to we're looking for T when my half-life is 2 months. Okay, so just like before, we cannot multiply 65 times 1/2. So to get rid of the 65 times, we're going to divide by 65. So 10 divided by 65 is 0.1538. 461538 equals 1/2 to the T over H power. So now I have my base, which is a half. It's isolated. So we're going to log both sides. And remember, the rule is the exponent goes in front. So it's log 0.1538 461538, exponent in the front, T over 2 log, I'm just going to use 0.5 instead of writing 1/2. Okay, remember we're solving, this is time, so divide by log 0.5. So plug that in your calculator. So log 0.1538, 461538, divided by log 0.5 is 2.70439718 equals t over 2. Put that over 1 and cross multiply. So I'm just going to go up here now. So I get t equals, so it's 2.7004399718 times 2 when we cross multiply is 5.400, and to the nearest ounce would be t equals 5. Okay, so, and that's months. I don't know why I put ounces. This is time. So this was to the nearest month. Sorry. Okay, so let's take a look at number 3. All right, so we have an alien radioactive isotope has an initial mass of 55 grams. After 6 days, there is only 1 gram left. What is the half-life to the nearest tenth? Okay, so let's write down the half-life formula. A equals P times 1/2 raised to the T over H power. All right, so we have this alien isotope, the initial mass, that's P. After 6 days, that's your time. We have 1 gram left, that's your A. And it says, what is the half-life? So that means we're looking for H. So we have 1 equals 55 times 1/2 raised to the 6 over H power. Remember, we're solving for the half-life. Again, divide both sides by 55. So 1 divided by 55 is 0.0181818, and it keeps going, equals 1/2 to the 6 over H power. Now we're going to log both sides. So it's log 0.0181818 equals, remember exponent goes into the front, 6 over H log, I'm going to use 0.5. Okay, remember we're solving, this is time, so divide by log 0.5. So log 0.0181818 divided by log 0.5 is 5.7813599714 equals 6 over H. Put 5.718 over 1, cross multiply. So we have 5.81359714H equals 6. Divide by 5.7813, 59714, both sides. And we get H equals, so 6 divided by 5.7813599714 is 1.037. And I have here to the nearest tenth. So this is going to be 1.0 days. So its half-life is approximately 1 day. Okay, so that's it. Everybody have a good day. Stay well.